The thin veil of gases that makes life possible is a story billions of years in the making. But did you know that our planet's atmosphere hasn't always been like this? The story begins about 4.5 billion years ago when Earth was a molten ball of rock. In its earliest days, the planet had no atmosphere. Instead, it was surrounded by a chaotic mix of gases from volcanic eruptions and impacts from space debris. This was Earth's first atmosphere, made mostly of hydrogen and helium, light gases that couldn't hold on for long. Intense solar winds from the young sun eventually stripped these gases away. As the planet cooled, volcanic eruptions became more frequent, releasing a new set of gases like carbon dioxide, nitrogen, and water vapor. This marked the beginning of Earth's second atmosphere. It was a toxic cocktail, completely unbreathable by today's standards. This atmosphere was much thicker than today's, filled with carbon dioxide, and it lacked one key ingredient: oxygen. About 2.4 billion years ago, something incredible happened, the Great Oxygenation Event. Tiny organisms called cyanobacteria began using sunlight to convert carbon dioxide into oxygen through photosynthesis, slowly releasing oxygen into the atmosphere. This was a game changer. For the first time, oxygen levels began to rise, changing the course of Earth's history. But it wasn't an instant process. It took millions of years for oxygen to accumulate enough to reshape the atmosphere. As oxygen levels increased, it led to the formation of another critical feature, the ozone layer. Made of a special form of oxygen called ozone, this layer began to protect the planet from harmful ultraviolet radiation from the sun. This was essential for life to move from the oceans to land. Without the ozone layer, life would have been bombarded by deadly UV rays. With oxygen in the air and the ozone layer providing protection, the stage was set for more complex life to evolve. About 600 million years ago, the Cambrian explosion saw a rapid increase in biodiversity, with new species evolving in Earth's oceans. And eventually, plants began to colonize land, further increasing oxygen levels and creating a more stable atmosphere. This paved the way for animals and eventually humans. During the Mesozoic era, also known as the Age of Dinosaurs, the atmosphere was rich in oxygen. In fact, oxygen levels were even higher than they are today, which may have contributed to the massive size of dinosaurs and the lush vegetation that thrived during this period. It's fascinating to think that the air back then was different from the air we breathe now, yet still capable of supporting such a diverse range of life. The sky above us is more than just air. It's a complex, life-sustaining system called the atmosphere. But what exactly is the atmosphere, and why is it so important? How this thin layer of gases surrounds the planet and makes life possible. The atmosphere is a layer of gases that extends up to about 10,000 kilometers above Earth's surface. But even though it stretches far into space, it's incredibly thin compared to the size of the planet. It's like the skin of an apple, thin, but crucial. Without it, life as we know it wouldn't exist. The atmosphere protects us, provides the air we breathe, and helps regulate temperature. So, what's in the atmosphere? It's made up of several gases. About 78% is nitrogen, 21% is oxygen, and the rest, just about 1%, is made up of trace gases like carbon dioxide, argon, and water vapor. This small amount of trace gases might seem insignificant, but they play a big role in weather patterns and climate. For example, water vapor is essential for forming clouds and precipitation. The atmosphere is divided into 5 main layers, each with its own unique properties. Troposphere, 0 to 12 kilometers where we live and where all weather happens. A stratosphere, 12 to 50 kilometers home to the ozone layer, which protects us from harmful UV rays. A mesosphere, 50 to 85 kilometers, the coldest layer where meteors burn up. A thermosphere, 85 to 600 kilometers, where the auroras occur and satellites orbit. Exosphere, 600 kilometers and beyond the outermost layer, gradually fading into space. Most of the weather we experience happens in the troposphere, the lowest layer of the atmosphere. Above that, the stratosphere contains the ozone layer, which is vital for protecting life from the sun's harmful ultraviolet radiation. The atmosphere doesn't just protect us, it also regulates Earth's temperature. The greenhouse effect, caused by certain gases like carbon dioxide and methane, traps heat from the sun and keeps our planet warm. But Earth's atmosphere has not always been stable. Throughout its history, there have been significant shifts, including the ice ages. Changes in greenhouse gas concentrations, like carbon dioxide, played a role in these dramatic cooling periods, as did shifts in Earth's orbit and solar radiation. Periods of higher CO2 led to warming, while lower CO2 levels contributed to colder, glacial periods. This delicate balance between gases in the atmosphere has always played a major role in Earth's climate. Fast forward to the present day. For the last 10,000 years, the atmosphere has been relatively stable, allowing human civilization to flourish. But in the past 200 years, industrialization and human activity have started to alter this balance. Burning fossil fuels, deforestation, and other activities have increased the levels of greenhouse gases, especially carbon dioxide. This has led to global warming and climate change, issues we are grappling with today. Without the greenhouse effect, Earth would be too cold to support life. However, too much of these gases can lead to global warming and climate change, which is why reducing carbon emissions is so important. The future of Earth's atmosphere depends on what we do now. By reducing emissions, transitioning to renewable energy, and protecting natural ecosystems, we can help stabilize the atmosphere and preserve it for future generations. Our atmosphere has been through incredible transformations, and it's up to us to ensure its stability for the centuries to come. So next time you take a deep breath, remember the billions of years it took for Earth's atmosphere to become what it is today. From volcanic eruptions to the rise of oxygen, our atmosphere has shaped life on this planet, and it continues to play a vital role in our future.